Hi guys, welcome to my shop. I'm Robin, and this is part 3 of the custom caliper series, and I'm going to be doing some of the final grinding, some slitting with the 18 thousandths wide grind wheel, and finishing up the calipers, assembling them. So it should be pretty interesting, and let's get started.
Here I'm touching a test part with the side of the wheel to be able to establish getting the wheel on center of the holes in the parts. I'm stacking the 4 real parts in the grinding vise. I have a little shim in the back there to take care of the minor radius that's there from the end mill on the back side. The lip on the back is hanging over the back of the vise there. Now we're touching down on the top with the 20 thousandths wide grinding disc, part off disc, about 50 thousandths deep, creep feeding through, another 50 thousandths creep feeding through. It's actually faster than reality there. It's probably 2 or 3 times sped up. The reason for the 50 thousandths at a time is to keep the arc of contact relatively short. If you did it all full depth at once, the arc of contact would get very long. Chips would start to erode the wheel. There's the slots finished down through the center. Allow that to flex and grip the part. Grinding the 45 on the jaws. Now we're putting the black silver solder flux on, getting the pieces in place. There's plenty of excess material on these, so the axial position of these in the slots is not critical as long as it's hanging over. Just making sure they're seating well. Now just using a little bridge piece and the clamps there to be able to put some gentle pressure on. Silver soldering is 99.9% preparation and experience. And there I'm putting the heat sinks on there. Got my little torch with the rosebud on it. The whole idea here is to get in there quickly, get that section up to temperature and soldered, and get it done. Get out of there so we don't fry the calipers in the process. And we'll pop the clamps off, go over in the sink, cool it off. There they are. Everything flowed nicely. These are 4142 material. You can see the flow was real nice there on the back. Now the other calipers needed a step milled in those aluminum blocks you can see there so that it grabbed because they're shorter. And here I'm using 2 washers that are flattened on there to hold these nice and flat and parallel together. Like I said before, preparation with silver soldering is 99% of the game, getting it exactly where you want it and getting it so it's not going to fly apart when it's red hot, which unfortunately happens too often. So we'll do the same thing here. We'll clamp them with that little balance bars there to spread the load between the two. Notice I've got my contact points of the jaws in between there so that the get the wiffle tree effect of spreading the loads evenly between the 2 clamping surfaces. Got the aluminum blocks on there, and this one's a little trickier because it's a lot shorter distance from the weld or the silver solder zone to the actual beam where the printed circuit material is on the beam that actually forms the measuring system. Yes, I need another hand, but I only have 2. Get these lined up properly and clamp in place, getting my jaws lined up so their center of pressure is nice and even. Anything that can go wrong while you're silver soldering will go wrong, as far as clamps popping and things squirming under heat. So same thing here, warm these up fast. This is sped up a little bit. Warming them up fast, getting them up to temperature real quick. Basically don't want that heat to have time to travel down the beam, and that's why we have the aluminum there to suck it out as quickly as possible. And that's it. Same thing, take it off, take the pieces off, go over, cool it off in the sink before we fry anything. Now we're on the grinder, getting ready to clean up the parts. We're sitting on the back of the caliper, but these 2 long jaws are floating, so those brass pieces are tapered, and I'm sliding them in until I get the support such that when I turn the chuck on, they both sit at the same uninfluenced level, so that I can grind across here, grind across the jaws to put that together. Way close enough for what we're doing. So now we just march across, taking the grinding them down until we get them to clean up, and just stopping right at the edge of the frame. And coolant helps here just to keep things working well. I use coolant 99% of the time. It's just one of those things where I got the grinder set up for it, and once you have it, it's just nice to use. Here they are after being cleaned up. There's one cleaned up on the left and the other one getting ready to get on the right. These are the face groove calipers, and we're doing the same thing here. They're hanging over the edge of the vise because they actually hang down below at the moment. And these are stiff enough to just hang out there in space without any support. Same idea here. We're going to touch down and touch on both jaws and grind across, just blending in the old with the new. And we're keeping the grind lay the same direction as what was on the original caliper. Not that that's essential, but aesthetically it looks nice to be matched up. There they are, cleaned up. Now we're trimming up the ends. This is just cosmetic here, parallel to the beam. On the same thing on the face groove calipers. And now we're having flipped over on their backs. On the part that we just ground, we're touching off on the back, and we want the that end to be the same height. So all we do is pick up our 0 there on that blue Sharpie mark, and we're just going down to the same level. That way, when you're doing something on the face, you can just lay right against it with the face groove caliper. That's just cosmetic there, cleaning up on the back. There's nothing critical about that height. Some of these things are purely appearance, but it's the quickest way to get a decent look on the calipers. It's quicker than any other thing you could do to get them to look professional. There they are, cleaned up. Now we're doing the edge grinds where things match up. I have my 1, 2, 3 blocks bolted together. They're my own design where they can bolt to each other in any combinations on any face. I'm just using them as a tall post to be able to hold things, because the tail of the caliper has to hang down below the edge of the table. So I'm aligned with the indicator on that. Now I'm just going to plunge down. I picked up my 0 for my height. I'm just going to plunge grind down till I've actually reached close to 0. Move over and get to one little spot. Now I'll just take a normal traverse pass across there and get a nice finish. So we're just matching with the original edge of the caliper and blending right across there onto the other material. And you can see why we left the excess material there. Just makes it a piece of cake to be able to match these things up. Same thing with the straight, indicating in, toolmaker's clamp there, just holding it, and my touchdown point there. And here I'm just going to run in until I run into the corner. Once I get my height, I'll run into the corner where that downhill bevel on this side matches, and just try to do my best there to make the corner match up nicely. Yes, most all of these things are sped up some amount to make the video more condensed. I like to make content intense videos, so that's why things are sped up in a lot of instances. There it is. Now we're doing the angled surface, trammed in there on that surface, and same thing here. We're just running in, and all this is purely cosmetic, but makes for a really finished looking product. All these little nuances are what makes a tool look like a great tool, or just a like somebody made it in the South 40 with a hatchet. Same thing on the inside edge of the face groove caliper. but these we can hold in the vise. And then this is the bottom edge of the ID groove caliper, which is parallel. Just doing the same match up there. Need clearance with the wheel guard off there. And then indicating in and feeling for the edge there, telling what's going on just with the edge of my scale there to tell whether I'm far enough across on my in and out traverse. These pieces are 4142 material, and they got a little hard from the silver soldering. So here, notice my DRO, my multimeter in the background there, set with the temperature gauge. So I'm taking them up to like 600 or 700 degrees to temper them back so that they're not too hard to machine. So they're still pretty tough, but the color difference is because the caliper beams are stainless and the other parts are regular steel. So that's why one was much bluer than the other. Two different datums on my digital readout, 99 on that side, because I need to be referenced to the original jaw. There's excess material on the brazed on part. Now I'm doing the spot holes for the 50 thousandths reamed holes. Doing the actual drill for the reamer. That's actually a printed circuit board, carbide printed circuit board drill that I'm using there. And there's the 50 thousandths carbide reamer. Just happens to be left hand, which with through holes is not a problem. Actually works better. Pushes the chips ahead of the reamer. Checking with the 50 thousandths gauge pin, and these are minus gauge pins, so they're typically up to 2/10 light, so that's perfect fit there. Little set there. They're very handy. That's the 11 thousandths to 60 thousandths, or 10 thousandths to 60 thousandths set. Very handy. You can see the finish in this holes is really nice from that reamer, and so we still have some more work to do on these. Now I'm setting up for the 080 clamp hole. This is the 3M 467 tape. This is double sticky tape that is just adhesive. There is no carrier, so it's literally adhesive only on that tape. Once I peel this off, all that's there is a strip of adhesive. There's no carrier, so it's very thin. Works really well, real handy. What I'm using that for is just to hold these parallels on temporarily to be able to grip the caliper where in the relieve section in the center there, without these things flopping all over the place. You'll see what I'm talking about. You can see what I'm talking about there, where I've got the relieve section in the center. It's thicker above and thicker below, and that lets me grab in there. Now I'm edge findering off the actual backside, and then I'm going to edge finder off the pin, because that's what I need to be relative to. Those faces will get ground off, leaving about 1/1000th of an inch of the pin exposed, sticking out from the face of the caliper, so that the pins touch themselves. Spot drill, and then the tap drill for the 080 thread. That's a printed circuit board drill, carbide. It's spinning much faster than that. That's the speed effect on the chuck there. It makes it look like it's a lot less. It was real quick there, but I drilled a 063 hole on the top half to clear the 080 screw. I'm just using the chuck to guide on the actual body of the tap to tap these. That aluminum ring is eccentric, so it looks like I'm wobbling that tap all over the place, but it's actually the eccentricity of the tap. Now here's where I'm coming in to grind off, and I'm going to be actually grinding 1/1000th of an inch into the edge of that hole, and that'll happen when I touch the face of the caliper down there at the bottom. You notice I'm actually infeeding a certain amount and then letting the OD of the wheel do the cutting. I'm not creeping in little light cuts with the side of the wheel. It's more effective to have the actual OD of the wheel do the cutting if possible. Angle gauge blocks, Brown and Sharpe. I just bought them maybe a year ago. Really handy. I should have had them years ago for setting up angles. They're really nice. One of my 1, 2, 3 blocks in there, sitting on there. and that's just there to get the 15-degree angle that I'm going to grind on the calipers here, somewhat for aesthetics, but also just to make the visibility of where the face grooves are going a little better. Tramming in the bar there, not that it's critical, but just to have it in the ballpark so that that flat is aligned. And I just have an actual flat washer there, bearing down on those to hold those while I plunge grind down on there to get the thickness that I'm after. There it is. Here I'm dressing the 20 thousandths cutoff disc to about 18 thousandths. Some of it's just get rid of the run out, but having the balanced, I have two core drills, diamond core drills in there. I just tapped them around until I got them to touch the sides of the wheel the way I wanted it, and dressed through. If you try to dress one side at a time on that, the wheel will just deflect away and possibly even just snap off. Indicating in the jaw to grind the slot. Notice the clearance here. The wheel is just smaller than the calipers full open. So I'm touching on the end there to get my location. And you can see up here the top is just clearing underneath the diamond. So I'm moving over the exact amount because there's not a lot of room to play with here with the size of the slot and that 50 thousandths hole. So same thing here. I'm getting location, creep feed down through 50 thousandths deep. Actually 100 thousandths deep, I think there. And then another 100 thousandths. Creep feed through again. The wheel works amazingly well, that cutoff wheel. They're not cheap. I think the thing was about 18 bucks. But it really holds up well. There's the slot and the whole clamp system there, so I'm pretty happy with that. Now it's assembly time. Taking the 080 Torx head pan head screws, threading them in with some blue moly lubrication on the screws there. Really like that blue moly lube. Just seems to be very effective, and you can see where it is. Putting the pins in. They're hard to get started because it's such a close fit. And now I have my caliper set for 0.1, which is the amount of stick out that they're after. That one wasn't out far enough, and I'm just using that to push the pin in, and then cinching up the seat there to grab the pin. Same thing on the other pin. Sliding it in to be able to set it at the 0.1. These calipers aren't super precise on the side-to-side alignment of the moving jaw, so you might see a little misalignment here of where they sit at rest. It's just the nature of the beast. There's no precise alignment there, but there they're all finished up. I did not show any of the deburring, chamfering. There you can see the actual silver solder joint there on the face. You just see them there. So now the electronic module goes on. When you're doing these screws, the high-low plastic screws, it's always good to back up and feel for when you're getting back into the original place that the screw started. If you're careless with those, you can recut new threads each time, and it's a really good way to just chew out the threads in short order. So you can see I'm backing up and getting a real good feel. And even with the high-low screws, it actually pays to make sure you're not you're in the right one. You can back up a half a turn again and get the one that goes in the easiest is the right one. Cinch them down and put the battery in, and just clean them off. jaws don't actually touch. Like I said before, the pins are what's touching, but there's only like 2,000 scaps, so if you have much dirt in there, you'd be in trouble. Here I'm putting the thumb roll support back on, and I'm going to be tweaking the gib screws here on this, feeling for play there, and then tweaking those, get them just right. They have a little red sealant on them, but they usually never have them adjusted real precisely. They're pretty twitchy to get them just right, where they're just tight enough that they're no play but don't feel draggy. So you got to fool with them quite a bit. Now we're going to put the back cover on it, and I'm going to use that same 3M tape again. Clean off the back with alcohol, put 2 strips of this stuff down. I got that from McMaster Carb, but that's really handy stuff for holding pieces together when you're machining or whatever. Just anytime you need a adhesive that's very thin and removable. Just trimming the edges off. And when you peel that backing off, you got nothing but adhesive. As usual, getting that backing paper off can be tricky. I have those little flat nose tweezers with the edges sharpened fairly thin just for that purpose. There's the sticky on there. Obviously the serial number and warranty is out the window after what I've done to these, but these things are pretty bulletproof. Here's the ID groove caliper, same thing. Putting the screws in to that grip the pins. Putting the blue moly on. Run them in, and then we'll same thing with these. Put the pins in. Make sure we have the spherical end out, and use the caliper set at 0.1 to control the amount of stick out that we have on the pins. Yep, there's the spherical end. Slide them in. Just snug them so that there's a little bit of drag. Setting the stick out. Stick out on the other one. There they are. They just need to fit in a 1-inch bore, and you can either set them with a micrometer or a 1-inch ring gauge and zero it, and then just add 1 inch to the reading. And same thing here, putting the cover back on, and I won't go over all that again. So there they are, finished. The ID groove calipers. Hope you enjoyed this content, and if you have any suggestions on future things, please leave in the comments. And thanks for watching, thanks for subscribing, and please share this with